My name is Mark Moore. I'm a retired physical scientist from the government, the Department of Defense, and we're presenting this little rock talk tonight and on Thursday night. I'm from the Withlacoochee Rockhounds, and we want to thank the Hernando Historical Society for providing this space and this time so that we can do it. What we're going to do is we're going to do a two-part program. We're going to do the first part tonight on rocks, and the second part on Thursday night we're going to go over fossils. If anybody's really interested, there's a tomorrow night the Withlacoochee Rockhounds down in Spring Hill. I'm giving a short talk down there on the Precambrian rocks. So with that, I'll introduce my other half over here. And you can't see her, she's off camera. She's sitting there going, no, 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 no. But she's the other half of the rock collector that we do, the collections that we do. This is a fossil. This is not a rock. Everybody thinks it's a rock. It's called Florida State rock, as a matter of fact, but it's really not a rock. It is really a fossil. It's fossilized coral, and we've talked to a couple of you about the water. There's water inside of this thing. What happens is the salt water plates out and forms crystalline structure and leaves fresh water. And so when they cut the thing open, if you get it out, there is fresh water in some of them, not always, but in some of them. We got to talk about rocks. We got to talk way back, and this is something I had to put this up here first because it gets confusing. What this is a diagram on the abundance of elements. Now we know that at one time this solar system, our entire system, the entire space in this area, was the site of a supernova. Okay, now how do we know that? Well, because in a normal sun, in a normal solar event, only iron is the highest weight element that you can get. You don't get anything higher. It doesn't fuse. There's not enough energy because like iron and krypton or iron and calcium diffuse and produce a heavier element. So all of these heavier elements, everything above iron, now that's not every last atom, I'm sure. I'm sure there may have been some cobalt or something in our sun that was produced, but by and large, it only produces up to iron. So all of these heavy elements came from a supernova. Okay? So we know that somewhere in this space environment, somewhere in the near space, it was produced. Now, the other thing that's important, not tonight, but for Thursday night, is this little dot down here. This is the percent abundance. In other words, there's more oxygen and silicon on in the Earth's crust than anywhere else. These are rock-forming elements. There's more of that than any other element. Here's uranium. Everybody thinks uranium is really rare. It's not. There's more uranium atoms on the Earth than there is bismuth, mercury, lead. No, there's more lead now. Back when the Earth was very new, there was more uranium than lead. But now uranium decays into lead. So now there's more lead. And here's thorium. But these are all they call this group rare earths, and they're not really rare earths, but you can see there's more of those than there are a lot of these other, and I really should have researched that and seen out why they call them rare earths, but they are. And that's this group in here. But what you really need to remember is, here is iridium. You ever hear about the dinosaur extinction? The theory, the fifth major extinction that we had? Well, the iridium layer, and I've got a piece here we're going to show you. Okay, I'm going to pass this around. This is a piece of earth from Spain. This is Spain. I have a guy over there, and he went. I told him right where to go, and he went and got me a sample. Now he's selling it on the internet. Figure that. But anyway, that is a piece. If you look really carefully, I don't know if you can see enough light in here, but the bottom of that half is a different color than the top. And that bottom is before the iridium layer, and the top part has got the iridium in it. So anyway, that's important to remember that. The other thing is just remember that up here is silicon and oxygen. And those are the most abundant elements. Now what is sand?
Silicon.
Silicon dioxide, or silicon oxide, or one of the oxides of silicon. What is that? That's silicon and oxygen. What is another real common one? right here. Calcium. Calcium oxide, which is another name is calcite. Okay? The calcium oxides, those are a really common, really common form. Now, when we get to here, there's three major types of rocks. And I'm telling you a general rule. There's going to be somebody, someone always does it to me, that picks up these small transitional things. There's a rock that's not quite a rock, or it's transitions. But generally speaking, there's three forms. There's the igneous rock, which is either volcanic, which means it come out and it cooled on the surface of the earth very quickly, or there's plutonic, which means it cooled down inside the earth. We have a slide here in a minute you can see. Cools down inside the earth, cools much slower. And it's one of those two, and that's principally basalt, obsidian, humus, and granite. Of all of those, there's only one that's plutonic. What do you think it is? Anybody? Take a guess?
Granite.
Right, exactly. See, it was a 1 out of 4, you had it. Yeah, I can use that thing a little bit. Yes, it's granite. And we can show you where in the plume code, if you show me a piece of granite, I can show you where in the code, in the form, where it was at, based on the crystal structure, based on where the crystals. We've got some granite here in a minute, I'm going to show you. And then metamorphic means it's a changeling. Okay, meta means change, and morphic is form, a change of form. And these are stuff like marble. Marble starts out as, anybody know? Limestone. Yeah. Okay, marble starts out as limestone, and under pressure, under pressure and heat, it converses, it goes through a couple of stages, and you wind up with marble. And then there's sedimentary. That's my favorite one. Why is that my favorite one? Anybody know? Can anybody take a guess? Well, it's because most of the rock we run across is sedimentary. Okay, because the Earth's been around for many billions of years. At least 4.5. That's in my talk tomorrow night. It's the age of the Earth, that type thing, and how they get those ages. But that is, anyway, that original rock weathers, okay, crumbles, falls into the water, falls down to earth, and it becomes dirt, which then gets sucked under and changed into your other forms of rock. And plus the fact that I just like things that sit quietly and don't cause a lot of fuss, So that's just something I happen to like. All right, minerals. This is it looks like a rock, but it's not. That's the best way I teach that to the kids. So when I talk to the kids, I show them it's not a rock. They look like rocks. For example, this is a big quartz crystal, quartz cluster. Everybody calls it rocks, but it's really not rock. It's really, what do you think it is?
Crystal.
It's a mineral. Crystal. It's a mineral crystal. Okay. What's the difference between a rock and a mineral? A rock can have a whole bunch of different minerals in it, and a mineral is only one. Okay, minerals are naturally occurring, inorganic, solid. They have to have a solid. You can't have a liquid mineral. Okay, they think you can. Like mineral oil, little kids say, "Look, we've got mineral oil." Well, yeah, you have mineral oil, but it's not really a mineral. It's an oil. And then it has a definite composition. Mostly compounds. Most of the time, it's a compound, like it's some sort of an oxide, or some sort of a sulfate or something like that. But it can be an elemental, like this is sulfur, and this is right here. Matter of fact, these are 3 I'm going to pass around to you. Okay? Go ahead and start them so they can
this is a calcite.
That's the calcite. That's calcite. That's a crystal. That's called, it's called Icelandic spar. And right now, it's a heavy fine if you take any Icelandic spar out of Iceland. It's like a $1,000 fine if they catch you taking the Icelandic spar out.
And this smells like sulfur.
But fortunately, they can't tell if it came out yesterday or 1,000 years ago. There's no way to prove it. Okay? What that is, that's copper. That's a piece of copper that came out of the earth up in. They said it was just elemental, but I strongly suspect that it was melted. That the Indians either prehistorically or somehow was It was melted, and that is a piece of sulfur, just pure sulfur. At our place in West Virginia, we used to have the creek right below my house, the house up there, had a sulfur springs in it, and that stuff just grew on the side of the springs. You know, you could have a little piece there today, the end of your finger, and by the time we get back down there, a month or two later, it'd be the size of a marble. Then it would be the size of a golf ball, and it just got bigger, and then of course somebody would come on and knock it off, or the rain would hit it, and it would tend to disintegrate again. I had a piece that one of the kids brought a big hunk about this big up, and they set it out on the front stoop. And we forgot about it. We just left it sitting there, and we came back, I don't know, a couple of months later. The next time we got back down, and there was nothing but a big yellow stain on the concrete where it had melted in the water, had melted it and run it down. Anyway, this Icelandic spar, did y'all ever hear of the Viking Sunstone? Well, what it is the Vikings would take a piece of calcite, and there's a dot. If y'all look carefully on that piece that's out there somewhere, there's a dot on the bottom. And what that is, if you look through that, if you look at it and you rotate it, you'll see that dot, you'll see two dots, and they'll move. Well, if you line that up just right, if your light source is coming from the sun, even if it's behind clouds, it won't work at night, of course. But if you just rotate it there, and you'll see the thing. Rotate it. You know, look at the dot, and then just rotate it like a clock. Don't turn it. Just rotate it. There you go. And anyway, that will point to the sun. The one axis will point always to the sun, and it works really good. I'm trying to get one that I can get the school kids to learn how to use it just for fun. Okay, because it is kind of neat when you get that thing locked up. And I've experimented with it because I have a clock, so I know where the sun's at. So I can take my clock on a cloudy day and I can say, oh, well, the sun should be right over here. And sure enough, there, you go out there and take your little sunstone, just set it right there. We'll get them all at one time. Okay. Okay. Igneous rocks, where do they come from? Where do most igneous rocks come from? Volcanoes. Okay, do all igneous rocks come from volcanoes? No, right, exactly. We're going to show you some that don't. Right here, this slide coming up now, this is showing you, this is the pluton. This is called a pluton. Remember we had the formations. Okay, well this is the plutonic. Where's the volcanic? It's up here because it's blown out and it cools up on the surface, or it cools up, up going up. But this is what they call an actively forming pluton, and this is a cooling igneous pluton. And this is where we get most of the granite. Most of our granite comes from one of these. Very rarely do we get it there. Why?
It's too damn hot.
It's too damn hot. It's really, really hot. So, okay, and then this is the different type. Basalt, obsidian, and pumice are volcanic, and granite is plutonic. Okay? Okay, here's the granite. And I knew I was going to get things mixed up a little bit, and I probably did. But anyway, here is two pieces of granite. What I want you to do is look really careful, because one of the pieces of granite has got...
Can we see it here?
Leslie, hold it up there.
This
so
one
you
right
can
here.
see it. Okay, one of them has got very big crystals, and one of them's got very small crystals. So if we go back to here, where do you think the big crystal piece would come from?
Deep in it.
Deep in it, right, way down in here, okay? And that's because as it cools slowly, it allows the crystal to have time to grow. Because once it cools, the crystal won't grow anymore. And so out on the outside, it cools really quickly, or it's still not really quickly, but it is quicker. If it cools really quickly, you get one of these that we've got over here. So that's generally speaking for most of the way the crystals form. I had a beautiful display to bring to you guys tonight, and I thought it cured. And I went to wash some of the vinegar off, and it took all the crystals, because you can take one of these little echinoids. Oh, the echinoids, that comes next to Thursday, yeah. And anyway, I'm going to show you how the crystals form. Maybe I can get another one to grow by then. But is there any questions on the granite? Okay, well here are some of the places that some of this igneous stuff comes from. This is basalt. Okay, this is a piece of basalt. Okay? Not only is, but where do you think that piece of basalt came from?
Spain.
I'm sorry?
Spain.
No. You were close. No, not really. That came from Antarctica. That came from McMurdo Sound in Antarctica. And I have another piece that actually came from the physical South Pole. You know, we had some work to do in Antarctica at one time, and they gave me a shot, and I got terribly sick from the shots. You have to go, you know, it's a restricted, closed spaces. They can't bring germs in there, so they give everybody the shot. So I get the shots, and what do? I get sick. So I had to send someone, and the guy that I sent, he said, well, what do you want to send me? Because it was a big deal. It was a big deal to get to go there. And I said, I want a rock. So he said, okay. So he brought me that rock, and then he pulls out of his pocket. He says, here's another one. I said, what's that? It's a little tiny rock about that big. He just happened to be in the right place at the right time. And he got a helicopter ride to the South Pole to pick up some instrumentation. And he walked over and picked up a little piece of the rock there right at the South Pole. Now that was 35 or 40 years ago. Is the South Pole the same place it was then? No, it's migrated several miles. So. But anyway, I was going to bring that, but I don't know what I did with it. I can't find it. Anyway, that's basalt, and here is some obsidian. Now, I'm going to caution you. Matter of fact, why don't you help people? Because this stuff is very sharp. That's a piece of show it to Gary. That's a piece of raw obsidian. That piece comes from Oregon. Okay, and it's getting harder and harder to find because people are picking it up. And this is what they do with it. This is the knife. Now, this was made by a friend of mine. And I got this. This is my clicker. Yeah, and this
Watch
is.
the edges, it's sharp.
Yeah.
Yes, would you bring that off your counter?
No, but isn't it beautiful?
It is.
This is a knife that was a friend of mine made for me out of obsidian. Okay, this is what the Indians, you know, not only the Indians, but it goes back in prehistory from Europe. They would make razors and stuff and cut knives. It was so sharp. Leslie used to cut chicken with it. Yeah, I mean, she was a hippie at one time. You know, and so, and I've dulled this because I've had too many people cut their hands on it. So I took and dulled this down. But you could shave with this. You know, when this was sharp, you could actually shave with it. You got it? Okay.
You're ready.
Oh, yeah.
Now I had a piece of this emerald.
Better put this one back.
Yeah, I had a piece of emerald, but I suspect that it's fake. After I got it, when I put it under my microscope and started looking at it, I believe that it's just colored glass. So I don't show that anymore. I used to show it. This was a piece right here, but it was too perfect. There were nothing impurities in it. It was just crystal clear. So I strongly suspect that it was fake. Gary, you running out of time? You got time?
Ray, can we call it? Yeah, Ray, call it.
Okay, we're going to take a little short break now, so I can put all the stuff away. It's only just a couple minutes, so don't go away. Stretch. I don't want to see anybody go to sleep.